Okay, hello everyone, and thank you so much for joining me for today's lecture. We're going to look into the summarizing of the data in epidemiology. So we're going to look into organizing the data, types of variables, frequency distributions, properties of frequency distributions, methods for summarizing the data, and we are going to come up with the measure of the spread, central location, and then the summary of what we learned so far. So this is what we get when we are looking into a data. Imagine that we are looking into a COVID outbreak, and we are looking into I would say, looking into the different variables in different places. So here we are going to establish a database. We're going to have different columns because we need to have, again, same variables in specific columns so that we'll be able to do the analysis. So here, for example, we put the dates. In this case, later in our analysis, we can look into the dates and in each date, how many cases we had. We can also look into towns. So we look into different towns and we'll be able now to look into the data of the number of people who had a disease, for example, a disease condition, in a specific city. So per city, it allows us to see if there's any city where we have a higher number of outbreaks, okay, which is very interesting. So you see, we just started talking about the data, but now you understand very well that the data itself, when it is taken well and it's well distributed and well presented, it can really help us in order to look into any pattern. Because, you know, when we have an epidemic, for example, we don't know what's the pattern. It is based on the age, gender, geographical location, what people they eat. Is it a pathogen, several pathogens? Is it any comorbidity? We don't know exactly. So we have to look into as many parameters as we can, but scientifically sound as well, based on the disease conditions that we are looking at. So we can look into the age of the people because maybe there is a relationship between the contagion rate and the age of our patients. We look at their gender or sex, same thing. Maybe this is sex related. Okay, it's not. I mean, whoever is male, for example, they are going to have a disease, but not females. For example, for hemophilia, we know that this is again a gene that is in mothers, and this gene is given to their sons. So when they have their sons, so when they have boys, I would say their kids are boys. We will see that in boys they have hemophilia. It's very interesting to look at the patterns. That's why I'm telling you here, for example, if people are hospitalized or not. We need to know if, for example, the degree of severity of an epidemic is to what extent. So if it needs hospitalization or not. Now you can see if, based on the age, the gender, the city, the time, if we have, again, people who are hospitalized or not. Then jaundice as well, or other outbreaks, if they are using IV, again, drugs, if they are having immunoglobulin, for example, again, deficiencies, etc. And this is just an example of a data that we can get, but don't forget that we are not going to look into 20 people, okay? Usually, if you're looking into COVID, for example, we look into millions of people. So here we need, of course, to have big and very, I would say, big and I would say and fast databases. So talking about the variables, we can talk about different variables. So for the variables, they can be quantitative or qualitative. Quantitative is the numbers, quantity, and qualitative is for variables that are having a quality, like your level of happiness or level of sadness of someone or level of pain, for example. These are all qualitative data. Quantitative data is like a blood glucose level or a number of the virus in a milliliter of blood. Now, for the scales of the variables, we can talk about nominal. They are categorical. So if this is yes or no, if a disease exists or not. We have ordinal values. So here we have, this is, again, it can be qualitative or categorical. Like, for example, in which stage we are, stage 1, stage 2, 3, or 4. In this, for a cancer, for example, here we talk about ordinal scale. We can also have a scale as interval. It means this is a continuous one, like date of birth. And then we can also have ratio. These are quantitative or continuous variables where we can look into, for example, tuberculin skin test. So with this test, we are going to see a number. So here, for example, you have some examples. I'm not going to read these. I let you, of course, go over this on your own. And then we can look into now, I'll just go over the exercise as well. The frequency of distribution. What is it exactly? We are looking into how many times a number or a variable has the same value. And we are going to put this frequency in a grid. This is very simple. So we are first, for example, if you're having 1,000 people and we would like to know what's the frequency distribution of the age, we're going to ask 1,000 people, what is their age? And you're going to see, for example, 3 people having the age of 5. In this case, the frequency of the age 5 is 3. So on a grid, we are going to search for X value, which is 5 years old, and Y value, which is 3, because this is the frequency. Example again, another one is we are going to have, for example, 200 people being aged 35. Then the age 35 has been repeated 300 times because we have 300 people being age 35. So on the grid, when we are going to put that on a grid, we are going to put it on the x-axis 36, and on the y-axis, the frequency, we're going to put 300. So now we are going to continue with doing this exercise. And for example, here we can see the number of cases. Number of cases here is, again, the frequency. And we are going to add them into a table. So here, for example, there's another distribution of the cases, for example. And what we get, of course, the frequency is something like this. It means that we are going to see the, for example, here, these are the dates and months, okay? And here we see the numbers. Those numbers of occurrence, this is the frequency. So now we are going to draw a curve, and you're going to see if the distribution of this frequency or frequency distribution is symmetric. If this is symmetric, it means that we can draw a bell-shaped curve. And in this case, we call that a normal distribution. If you have normal distribution, then we can use statistical tests that we call parametric tests, such as t-test. But if you look at the spread here, and you see that the curve that we can, again, draw here is not symmetrical, and it is not, again, a perfect bell-shaped curve, then we can call that a skewed curve. Now, the curve may be skewed to the negatively or positively, so to the left or to the right. And in this case, since the distribution or the frequency distribution is not, again, normal, we call that non-normal distribution. And in this case, we cannot use parametric tests like t-tests. We will need to use non-parametric tests like Wilcoxon test. That's because the distribution or the frequency distribution for our data is not normal. It's non-normal. So this is just for talking about, again, this. We also can talk about the central location and central tendency, where when we would like to look into a central tendency of the data, we are going to do an average. And we will see that the average, for example, of our data is here. We also need to look into the median. And when we have the same value of the median and average, In this case, this will indicate that our distribution or the frequency of the distribution here is normal. But if the value of the average is not the same as the median, it can be an indication that we don't have we have a non-normal distribution because the distribution frequency curve is skewed. And in this case, we cannot use the same statistical tests. So this is what we call a normal or bell-shaped curve, which is a normal distribution. There is a symmetry, and the median value and the average are the same. So we can, in this case, use parametric tests. For example, we can use t-tests. We can use paired t-tests. We can use ANOVA. We can use ANCOVA. These are different tests, statistical tests that we can use. However, if we have curves, a curve, for example, here, which is not symmetrical, in this case, we are going to have different central locations. Now here, we can look into the spread. We can also measure the spread. But this is the third property of a frequency distribution, which is its shape. Now, the graph of the three-dimensional frequency in figure 2.4, which is this one, were completely symmetrical frequency distribution of some characteristics of human populations, but tend to be symmetrical. On the other hand, the data on parity in figure 2.5 that we're going to see are asymmetrical, and they are commonly called as skewed. So here, we don't have a normal distribution or a bell-shaped curve. We have a skewed frequency, I would say, distribution. And in this case, we cannot use, again, t-test or ANOVA or ANCOVA. These are, cannot use the parametric test. We can only use, again, non-parametric tests. Perfect. So now we looked into the methods for summarizing the data. We can have different scales for the data that we have. We have quantitative and qualitative data. Now we can have these different scales like nominal, ordinal, interval, or ratio. And in this case, we can now see if we need to measure the central location. It means if we can look into the median or calculate the average. If this is we are dealing with a nominal or ordinal scales, we don't need to measure the spread or measure the central location. We are going to look into measuring the interval and the ratio. And this is going to allow us to make assumptions, to draw conclusions based on statistical tests. For example, if you would like to look into again how COVID, for example, was spreading in a city, we would look into again dates, and we would look into the areas, and we would see that I would say with when we're advancing in a month, for example, depending on the days of the month, we were looking into a higher number of people who had COVID symptoms in more and more areas in the city. So here we were looking into the number of the cases, of the frequency. We would look into the dates, so the days of the month, to see that there is a progression and that there is a relationship between the days of the month and an increasing number of COVID cases. So this is why we need to use methods to summarize data. We need to put our data in tables. We need then to look into the frequency distribution. And then based on the frequency distribution, we are going to see, for example, we're going to ask if the number of cases of COVID, for example, in a city were different at the beginning of the month, where we have our table and all of our data, compared with the end of the month. And if we see that there is a change, there is a change in the number, now downward or upward, we can use statistical tests in order to compare those two sets of data at the beginning of the month and at the end of the month. And then this is where we found out that COVID was, again, it was a contagion. And the same thing applies when we had less and less case of COVID, where we were looking into the number of COVID cases at the beginning of the month and then at the end of the month. For example, it could be end of a week, end of the year, okay? And then we would see that there is a trend. The trend could be decreasing or increasing. At the end of the COVID, for example, epidemic, we found out that there is a decreasing trend and we were less and less cases of COVID. But again, based on the data that we had with the frequencies. So now for talking about the measure of central location, obviously we have different measures. We have a set of data. We can just calculate the average, or we can calculate the median. Okay, so here again, these tables are telling you examples for finding the median or the mode. So this is the data that we have. For the mode or median, we're going to look into the middle value for the values. If not, for example, for the LOS, we are going to calculate the sum of all of those numbers and then divide by the number of those variables. And in this case, we would see the average. And when we compare now the average with the median, we'll be able to see if there is any, again, if the distribution is normal or non-normal. If the distribution is normal, then we can use parametric tests such as student test. If the distribution is not normal, then we cannot use parametric tests such as a t-test. We have to use non-parametric statistical tests. And again, for those, it's very easy to find them, of course, in different statistical databases. So after this, of course, these are just exercises, so I'm going to bypass those exercises. We can also look into, again, these are all exercises, so I will not go over those. Here we can see, for example, this is a skewed distribution. So in this case, we are not having a bell-shaped curve. This is a skewed, again, distribution where we need to use non-parametric tests. Then, of course, we can look into, these are, again, different assignments, also exercises. These are mathematics, okay? Don't forget that we are looking into epidemiology here. So I'm using this, again, this chapter in order to talk about the epidemiology and the tools that we use. The aim is not to, again, teach statistics, of course, but we just need to understand what are the variables, how the frequencies, how they are distributed, and how we can use what type of tests. So measure of spread, again, this is where we are going to look into to what extent we have the spread of our data. So here we can see other parameters like the range, like interquartile range or standard deviation. Standard deviation is the average of the difference or distance in between the central point, which is the average, or the mode or the median, with each of the data points in the data set. For example, if you have again numbers from 1 to 20, and in the middle you have 10, which is the average, the standard deviation is going to give you the average of the difference in between 10 and 11, 10 and 12, 10 and 13, etc., and the difference between 10 and 9, 10 and 8, 10 and 8, and 7. That's because 10 is the central point, and other points, these are all other data points. And the standard deviation is giving you the average of the distance in between the central point and other data points. This will allow us to do what we call descriptive statistics, where we are going to show the data without doing any analysis. We just describe the numbers, and we are going to also to use the average or the median and the standard deviation as well. But if you would like to do statistical tests, in this case, we will need to obviously have access to the data and then to use the data analysis tools. So here is we're just talking about different percentiles or interquartile quartile ranges. So it is another way that we can show or we can describe the data. It's one way, but again, we in epidemiology, we can choose our own tools. We are not going to systematically use each and every of the tools because they may not apply. But here, for example, you see the median, you see we are talking about the minimum value, about the maximum value. Here we are just describing what we find out. Because when we have a set of data, we need to describe the data. So we have to start somewhere. And when we start somewhere, we are looking into defining, of course, our variables. We're going to look into, okay, what are those variables? Are these qualitative? Are these quantitative? Then we are going to, again, use this descriptive statistics to show the variable. Now, sometimes, again, we may use a median. So we're going to say, what is the median? Again, it's the way to explain, to describe the variables. And then we may also have, again, calculate the average. Here again, we are going to calculate the average. We are going to, again, use it in our descriptive statistics. And if applicable, we are going to use statistical tests. But for those statistical tests, the question is, which test are we going to use? The answer is that we have to look into the distribution of the frequencies. If the distribution is normal, then we can use parametric tests. If the distribution is not normal, we have to use non-parametric tests. Perfect. So here we talk, okay, now, of course, you are much more familiar with the, again, with the interquartiles. So these are ranges that you can explain your data again. You cannot do any statistical analysis, but you can describe. There are different ways to describe. Of course, here you can talk about, again, your data set. You see, look at the frequency. You are looking at the percentage, and then you're going to calculate the cumulative percentage. This is a way, again, to should talk about your frequency of your data. Then we can talk about the standard deviation. Again, I already explained that as well. You have to calculate the arithmetic, again, mean or the average, and then you're going to use statistical analysis tools in order to calculate the standard deviation, okay? Again, the aim is not to ask you to do the mathematical, I would say, calculations, even if you need to know how they are done, but mainly which calculations, with which parameters you're going to calculate using a statistical tool like SPSS. And nowadays, of course, many again, students, they use also R, which is again another statistical tool, but many AI, artificial intelligence generative tools, they can also provide us with calculations for different statistical analysis. Of course, so far, AIs are not at 100% valid. So I always ask my students to use AI to learn about the language, of course, to test it. But again, for now, they have also to revalidate or validate the results that they get from different artificial intelligence generative tools. But obviously, in the next 5 to 10 years, even sooner, we are going to see that we are going to have more reliable AI tools where we'll be able also to do our statistical analysis and getting more, again, insights and more, I would say, doing more calculations, faster calculations, because again, from the very beginning, the fundamentals for getting AI was to deal with or analyze the huge amount of data that we have. So we have been accumulating data for decades, and with the tool that we have, the AI, it's giving us more tools in order to analyze the big data that we are having. And of course, this tool is also useful. It will be useful for the epidemiology as well. So here, talk about under the area a normal curve. We can also calculate this. This is another way that we can, again, talk about the differences in between different here segments of a curve of a distribution. This is in case we need to look into a different area under the normal curve with different standard deviations. But again, this is for explaining. This is descriptive statistics. You may not find all of these tools used in all of the epidemiological studies. Still, these are the tools that we need to know that they exist, and we can use this type of tools or this type of analysis for descriptive statistics. And then here, standard error is again another term, which is, it means that we are having an average. And the standard deviation that we are calculating is allowing us, of course, to calculate the standard error. So you see, first for the steps is that we are going to calculate the standard deviation for our data, and then we divide the standard deviation by the square root of the number of observations. In this case, we are going to find our standard error, and when we are going to show the data, any data point, we will be able to add the standard error, which is plus or minus, for example, a number. So we may have an average which is 10, but we have a standard error of 1.67 here. So in a graph, we are going to show that data point as 10 plus or minus 1.67. So on a graph, we are going to, again, have a vertical line on the top and the bottom of that average 10, and we are going to add 1.6 on the top and minus 1.67 at the bottom. So here we are representing the data. Again, this is a representation of the data error. If you would like to do any statistical analysis, you will need to put or do the input of all of your data into your database analysis tool, and then to do your statistical analysis. So now here, we talk about the right measures of central location and spread. So here you remember that we talk about a symmetric distribution, which is a normal distribution. It's a bell-shaped curve. And here you do have the skewed distribution. And in the skewed distribution, you have the mean, which is different from the median and the mode. However, in the normal distribution, where we can have a t-test, for example, or ANOVA or ANCOVA tests, we have the mean, median, and mode that are having the same value. If you have a non-normal distribution, you will need to use non-parametric tests, such as, again, Wilkinson and others, of course, but you cannot use for this type of frequency of distribution. You cannot use t-tests, for example. Okay, so these are just examples. No, I'm not going to go over again the remaining. These are just examples of the questions that I just wanted to show you. So my friends, we just looked into this chapter. That was, okay, so we were looking into the chapter related to the summarizing of the data for the epidemiology. And I hope that you enjoyed, again, today's lecture. Thank you so much.